So here's the architecture of this project. Whenever a user, say from a browser, places an order, first it hits the API layer. This backend handles all the routes like order, user, trades, ticker, and market. This is the only point of contact between client and the system. So whenever a user wants to check their balance, latest trades, and market depth, it all goes through here. So now if it's an order create request, this will go from here API/order. But API doesn't handle this directly. Instead, it pushes the request in this order queue, which is a Redis queue. Because we want to offload the actual processing and keep the API stateless. The API doesn't even know about the user balance and the order book. It just authenticates the user from the cookie and forward their request to this order queue. Then comes the matching engine, which is heart of this project, and this engine process each request at a time, like sequentially, because concurrency in trading can cause a race condition, like two users grabbing the same order at same time. So to avoid that, engine picks order from the queue one by one. There will be an infinite loop and this will pick order one by one, and then it will validate funds if both the users are capable of this exchange buying any crypto, and then it log their balance, and then it updates the in-memory order book. So engine does not accessing the database directly. Instead, it's creating an in-memory order book. And if a match is found, it performs the actual asset swap, like exchanging SOL for USDC between two users, and updates both the balance accordingly. So to ensure reliability, the engine state is replayable. Like if a matching engine crashes, we can recreate everything by replaying the queue from the start, from the beginning. But as the queue grow, that become inefficient. So we periodically store a snapshot, a full capture of user balance in the order book, and store it to S3. And in any condition engine crashes, we resume from the latest snapshot plus the current events. Next, once the order is matched, the engine uses a Redis Pub sub to notify the API about what happened. Like if we go to this doc, if an order is executed successfully, it will return a response of fills and executed quantity, like what is at what price, what quantity, commission asset, and trade ID. So it will return like how much executed quantity and fills will be an array. The API had directly subscribed to this pub sub with a unique message ID. So when we are putting our request in this order queue, we are also creating a unique message ID, and we are passing them as a pair. So it receives the result and sends the response back to the user in the front end. So we also have a WebSocket server running. Users subscribe to a specific market stream, for example Sol USDC, Ethereum USDC, Bit USDC. The engine publish updates like depth updates, trades, ticker, and changes through this Redis Pub sub. We can connect user to this WebSocket and then this WebSocket directly to the engine, but that will be an inefficient approach because we cannot scale that thing. So the WebSocket listens to this Redis queue channels, and this engine publish updates and pass it to WebSocket server. And when a user first join any market, like if I join this market of Solana, Sol, then we are sending a subscribe message to depth, trades, market price. So all that users who are subscribed to this single channel will get back the market updates. And when a user leaves, we also have to make sure they unsubscribe to this market or to this WebSocket. And for that, we are using singleton pattern to ensure single user manager instance across our whole platform. And finally, once the trade is matched, instead of directly writing it to database, we offload it to a Redis queue, like what trade is created, what is price, and what the quantity. And we have a separate database processor which pick this up and store it in a time series database which is running in a Docker container. It can be a simple Postgres database. And this database processor enables the creation of candle data generation. Like for this, we have to create a candle data, and database processor is responsible for that, like high, low, close, and this is crucial for chart and analytics. So here is the complete view of this crypto exchange architecture. Thank you. So here is front end of this app. Here are all the cryptocurrencies that we can exchange. Here are its prices, market cap, and 24th volume. And when I select any cryptocurrency to exchange, like Sol USDC, like Solana for USDC. So as I said earlier, when a user first visits a market, it sends a subscribe message to WebSocket server to get real-time update about trade, publish order, depth, and ticker through Redis queue from engine. So here we can see in WebSocket server we have sent subscribe message for ticker, for keyline, and for depth. And here we can see the real-time ask and bids of people who wants to buy or sell any crypto. And here is the real-time update about market price, 24 change, high, and lows. And when a user leaves, we also have to make sure to unsubscribe to this WebSocket server, so we stop receiving message for this currency. And here we can see we have sent unsubscribe message for ticker, keyline, and depth. So now let me show you backend of this project. So as I said earlier, to run backend, we have to start 5 processes that will run independently but work together. So first we have to start API, matching engine, and then Docker container to run time series database and Redis Pub sub, and then WebSocket server, and at last frontend. So I have already started Docker, which is running time series database and Redis. So now I have to start API, which is API backend, which is running at port 3000, then engine, then WebSocket server to publish trade updates, and then frontend, which is running at 3002. So as I said, when a user first visit any market, it sends a subscribe message to get real-time updates. So when I refresh this and go to its network tab, and here we can see it is fetching depth from the backend, trades, and ticker to fill this initial order book. This is coming from my database, from my recent and latest snapshot which I have stored. And we are also sending subscribe message for ticker, for keyline, and depth for Tata INR. So to test this project, I have hard coded some values in my order book, like for Tata currency I have base currency as INR rupees and cryptocurrency as Tata, with two user 1 and 2 to test this. So let's suppose I am a user with user ID 1 and I want to buy one quantity at price of 2050 of Tata currency. So when I place my order, there is these all people wants to sell their order and they are suggesting best price as 2040 of size 3, and these people want to sell at price of 2100 of size 3 as the best price, but I want to buy, so there are no user who wants to sell at this price, so my order will sit on this order book. So here you can see my order, and we are also getting a real-time detail about this order. So I can place another order. So still there is no user who wants to sell at this amount of price. So I will sit on this order book. Again, let me increase my price, and I want to buy at 2080. But still there is no user. So let's suppose I am a user 2 with user ID 2, and I want to sell single quantity of Tata currency at price of 2080. So I can see this is the best price I can sell because these people wants to buy at this amount of price. So this is the best price. So when I place my order, I will find this match and I will eat up this order book by fulfilling this single order. So when I click send, you can see my order decreased by 4 to 3. Again, I will eat up this order, and again. And we are also getting real-time update about which order got fulfilled, and also I am getting response that this amount of quantity that is executed with order ID this, and these are fields that order details. And all the people who are currently subscribed to this market will get this real-time update through WebSocket. Thank you.